A very good morning, I bid to all, especially our lecturer, Dr. Aliza. We are from Group 2. My name is Kanina Dominic Chita and my metric number is AF240007. And today we'll be presenting on our project. Allow me to begin with introduction. In this project, we are looking into how well open drains and swales can handle surface runoff, especially during heavy rain. These systems are commonly used to manage stormwater in both urban and rural areas, but their performance depends on things like the slope, shape, and surface of the channel. Our goal is to understand their capacity and see if they are effective enough to prevent flooding and erosion while meeting basic design standards. Moving on to the problem statement. For our project, there are four problem statements. Firstly, open drains and swales are often used to manage rainwater, but their capacity is not always clearly understood. Secondly, during heavy rain, these systems often overflow or cause erosion, but because they are not functioning as intended. Thirdly, poor design and lack of maintenance make the problem worse, especially in areas with increasing rainfall. Finally, this raises the need to properly evaluate their capacity to ensure they are reliable during storm events.
The first objective is to estimate the flow of the open channel drainage system. This is essential to understand how water behave in open channel such as river, canal and drains. Next, we aim to analyze the key parameter of the Manning equation. This includes the Manning roughness coefficient, which represent surface resistance, the hydraulic radius, which is the ratio of the flow area to the wet perimeter, and the channel slope, which affects the gravitational force driving the flow. Understanding this parameter helps us to determine their individual and combined influence on flow rate. Third, we aim to understand how these factors influence the flow rate, helping in better design and maintenance of drainage system. Our fourth objective is to apply the Manning equation to real-world scenario, evaluating how effective and practical it is when used outside of theoretical calculation. Lastly, we assess the accuracy of the Manning equation in predicting flow rates for different types of open channels, ensuring reliability in diverse conditions.
Assalamualaikum, my name is Muhammad Sharnizam bin Muhammad Nazri. My metric number CF240327. For this part, I will explain briefly about the result that achievable from the calculation that conclude. So for the channel that near Perpustakaan Tunku Tun Aminah, the length we study is 8.2 meter. The type of lining is the grass line. The Manning roughness coefficient is 0.03 and longitudinal bottom slope is 0.1952. This is the dimension for the channel, which use the AutoCAD. So the result that we achievable is for the area of flow, we get a 1.2375 meter square. For the wetted perimeter, 3.5728 meter, and hydraulic radius, which is R, is 0.346 meter. For the velocity of flow, we achieve that which is 7.32 meter per second, and the capacity of Q, which is Q, we get the 9.06 meter square per second. For the second location, which is PPUK, the length of the channel that study is 0.62 meter. The type of lining is precast concrete reinforced, and the Manning roughness coefficient is 0.01. The longitudinal bottom slope is 0.001, and the this is dimension of channel. We get the result for the area is 0.466 meter square. For the weighted perimeter, we get 2.380 meter. For hydraulic radius R, we get 0.196 meter. And for the velocity, which is V, we get 0.74 meter per second. For the capacity of the drain, which is Q, we get 0.345 meter square per meter cubic per second. That's all from me. Let's move to the next presenter.
Moving to our reference, the first source is Open Channel, Hydraulic by STEM TW, published by McGraw-Hill Education in 2010. This book offers fundamental insight into open channel behavior. The second reference is Wastewater Hydraulic Theory and Practice by Hegel W.H., published in 2000 by Springer. It provides detailed theory applicable to both clean water and wastewater system. Lastly, we use a 2023 publication titled Uniform Flow Depth in Trapezoidal Open Channels by A.R. Bataha. This paper helped us better understand modern approach to analyze non-rectangular channel profile.
Assalamualaikum, my name is Intan Nurai. My number matric is CF240395 and I will continue our slide presentation with conclusion. Okay, this is a drain A which is at PTTA, Perpustakaan Tukutun, Amina. The types of the drain that we get is grass line open drain. The roughness coefficient, which is N, is 0.030. The dimensions is 2.3 meter for the width times 0.45 meter for the depth. And the velocity that we get is 7.32 meter per second. The flow capacity, which is Q, that we calculate is 9.06 meter cube per second. And the freeboard is 50 millimeter. So this is a drain B which is at PPUK, Pusat Pengajian Umum and Co-Curriculum. Okay, for this type of drain B is precast concrete drain. The roughness of coefficient, which is the N, is 0.014. The dimension that we get is 0.6 meter for the width and 0.5 meter for the depth. The velocity that we calculate is 0.74 meter per second. The flow capacity, which is the Q, is a 0.345 meter cube per second, and the freeboard is 50 millimeter too. So for the conclusion that we get is, drain A has a larger dimension and higher flow capacity more than a drain B. Second one is, concrete lining at the drain B offers more smoother flow, but it's limited by a smaller size. The number 3 is, slope and material is significantly affect a flow velocity and capacity. So the proper design of the drain size, slope, and the surface material is crucial. So the data-driven hydraulic design is supports flood prevention and infrastructure resilience.